everybody, what we're going to do today is we are going to work from the CCNA Security version 2 lab manual, and we are covering today implementing firewall technologies on chapter 4, and the specific lab is 4.4.1.2 and it's configuring zone based policy firewalls. As you can see, I'm using GNS3 to actually do this lab. I'm hoping that we can get through the lab and implement everything as suggested in the lab manual. We'll hopefully get to see how zone-based firewalling works. Okay, so I've already set up the topology. No configurations have actually been done yet, so we're going to begin with doing that. So for those that have actually got the version 2 CCNA Security lab manual, just follow along. For those that haven't and would like to know how to actually configure zone-based firewalls, this video should help you or show you how this can be done. So we're going to start with part 1, which is basic router configuration, and what we're going to do is we are going to configure basic settings for each router. So by that, we're going to configure the host names, we're going to configure the IP addresses as per the tables shown in the lab guide, and we're also going to configure the clock rate, okay, for the serial interfaces. So I'll start with router 1 and I'll work my way around. Let's power all these on. And I'll just open all these tabs really quickly so we can flip between. Okay, so we'll start with router 1. As we can see, because I've already named the actual router, we do not need to configure the host name. However, just for video purposes, I will go ahead and show you how to configure the host name. And it's as simple as that. So now we're going to configure the IP addresses. The interfaces I am using are slightly different to those in the lab. However, please do follow along. And because this interface on router 1 is actually acting as a DCE, we do need to configure the clock rate, so we'll do that now. Okay, so with this version of router that I'm actually using, it's not going to allow me to configure the clock rate. However, to do this on a router that does support that, if you're working in Packet Tracer, you can just type in on the interface level the clock rate followed by the number. I'll move over to router 2. we'll do the same on router 3. Okay, so that's the router interfaces set. So what we're going to do now is we're going to configure the IP addresses on the PCs. As I'm using GNS3, I am using the virtual PCs. So I'm going to configure these now. I'll start with PCA, then move on to PCB, then lastly PCC. The command was IP Okay, so we'll see if we can ping the gateway. And as you can see, we can ping router 1. So we'll move on to PCB. Then we'll perform the same check again. And that's successful. And lastly PCC. And we'll perform the same check. And that's successful as well. So to prevent the router actually looking up or attempting to translate anything, we're going to enter the command no IP domain lookup on each router. And that's step 3 done. So we're going to move on to step 4, which is configuring the static routes for each router. So we'll start with router 1. We're going to do a static default route. And that's pointing to the next op interface, which is 10.1.1.2. Okay, we'll move on to router 2, and what we're going to do is we're actually going to point routes to each destination. So we'll do IP route 192.168.1.0, so anything going to that network with a /24 subnet mask, you need to route it via the next stop interface IP address, which is 10.1.1.1. We'll do another IP route, anything going to 192.168.3.0 with a subnet mask of 255.255.255.0. We need to route this via next stop interface 10.2.2.1. And last but not least, we need to do the same for the 33 network. So we're going to do 192.168.33.0/24 subnet mask, and that's also going via 2.2.1. And last but not least, we'll do the default route pointing out to router 2 from router 3. And the next stop is 10.2.2.2. Okay. So that completes step 4. Moving on to step 5, we've already configured the PCs, so what we're actually going to do is we're going to verify connectivity. So we're going to ping from router 1 to router 3. So we'll ping 10.2.2.1, and we can see that that's been successful. So we know that them static routes are working. Okay, we need to at this point make sure that the pings are successful. If not, you need to go back and troubleshoot until you can actually get successful ping from router 1 to router 3. What we're going to do is we're going to ping from PCA to PCC. Okay, so we'll do that now. To 33.3, I believe it is. Is that the right one? Yep, it is. So we can see there that the pings are successful, so it can get across the network as well, which is good. Okay, so in the lab guide, it tells us if we can ping from PCA to PCC, we've demonstrated that end-to-end IP reachability has been achieved. If you cannot ping but the device interfaces are up and the IP addresses are correct, use the show interface, show IP interface and show IP route commands to help you identify the problem. So as I say, at this point we should make sure that we have full connectivity across the network. So moving on to step 7, we're now going to configure user account, encrypted passwords and crypto keys for SSH. Okay. So the first command we're going to use is the security passwords minimum length 10. So this is going to ensure that any password we use is going to have a minimum length of 10 characters. Okay, just to make it a little bit quicker, I'm just going to copy that command over. Okay. So you need to do that for all 3 routers like I've just done. Now we're going to create a domain name. The domain name is going to be called CCNASecurity.com. And again, I'm going to just copy that across to the other two devices. The domain name is required in order to create SSH keys. Okay. So now what we're going to do is we're going to generate crypto keys for SSH. So to do that, we'll do a crypto key generate RSA, general keys modulus 1024. Okay. So as you can see, it's enabled SSH as well now. So we're going to use the same command. And we're going to do the same thing for the other two routers. There we go. And again, there we go. I do advise, if you are new to the command line, that you actually type out the commands a few times on all the routers rather than just copy them in. I'm just simply doing that because it is quicker. So now we're going to configure admin O1 user account using algorithm type script for encryption and password Cisco 12345. So let's go with this. So we're going to do username admin O1 algorithm type, and if we question mark it, we can see there the different algorithms. So we've got MD5, script, and SHA-256. Okay, so for this we're going to use script with a secret of Cisco 12345. Okay. So once we've done that, we're going to configure the line console 0 to use the local user database for logins. So by that it means it's going to use the router and its database to query when a user tries to attempt to access the console line. So to do that, we'll do the following. Line con 0. And we'll do a login local, and we'll also do an exec timeout. Oops. Of 5 minutes. So if the user is inactive for 5 minutes, it's going to time the session out. We'll also do a login synchronous for the console messages. We're also going to do the similar thing for the aux and the VTY. I'm going to change the transport input to SSH only, so that it's not going to accept Telnet. And we are done. So what we're going to do now is we're going to just do the same commands on the other two routers, and we'll go ahead and save the configurations. So we'll just do So that's router 2 now done. In fact, I just need to, I don't think we created a password for this one. So what I'm going to do is we'll just quickly create the same password and the same user. And last but not least, router 3. Okay. And we now move on to, in fact, before we move on to part 2 of actually configuring the zone-based policy firewalls, it's also asking us to enable the a password. So what we're going to do, enable algorithm type. I'm going to use script again, secret, and it's class 1, 2, 3, 4, 5, and we'll do the same on the other 2 routers. I'll just try to copy and start again. And a copy and start. So now that we've done all the initial configurations, we can now move on to part 2, which is configuring a zone-based policy firewall. So we're going to, in step 1, verify that we still have end-to-end connectivity. So we're going to ping from router 1 to router 3. I still have the command. There we go, so that's successful. And then we're going to ping from PCA to PCC, again, just like we did before. So the first few will time out, and as you can see we have replies there, so if we just run it again, there we go, we've got replies which are ping from PCA to PCB. Okay, so we're going to ping 192.168.3.3, and again we have successful replies. Okay, so now we can move on to step 2, and it's asking us to display the running configuration of router 3. So if we just do this, I won't answer the questions in the lab manual. I will just run through what it's asking us to do. So in fact, it's asking us to do a show IP interface brief to verify the correct addresses were assigned. Use the IP address table to verify the addresses. Okay, so we verified connectivity. We know that these IP addresses are correct, so we have nothing to worry about. We can see that they lines up and the protocol's up. So, and obviously we've tested connectivity already. So now we need to do a show IP route to verify it as a static default route pointing to router 2 serial 001. So we know that the serial, well, in our case, serial 20 on router 2 as an IP address of 10.2.2.2. So we do this IP route static, or we could do a show IP route as normal. And we can see that our static route is at the top and it's going via 10.2.2.2, which is router 2 serial 2/0 interface. So we know that that's correct. So what we're going to do now is we're going to create a zone-based firewall. This is task 2 of the version 2 lab manual. So I'm going to jump straight to creating the security zones, and it looks as though we are working on router 3 for the initial configurations. So as you can see in my topology, I have an internet zone, which is here. I have a conference room zone and I have an inside zone. So these are the 3 zones that we're going to be working with around well, to do with this lab. So to create these zones, we're going to start by global configuration, and we'll do zone security, name one inside, which is going to be the inside zone where 192.168.3.0/24 resides. Okay, we're then just going to exit out of that one, and then we're going to do another zone. We're going to call this one conference room, or conf room for short. Exit out of that, and we're going to create another zone, and we're going to call this one internet. Okay, so that's step 1 complete. So now we're going to move to step 2, which is creating security policies. So we're going to start by creating class maps. So I won't read what the lab is telling us, well, is explaining. For those that are studying the CCNA Security, should already have covered this and should be fully aware of class maps. Okay, so we're going to start by creating a class map. Class map type, inspect, match any, inside protocols, yeah, so that's fine. So now we're going to match TCP, protocol TCP, match protocol UDP, match protocol ICMP. What this is doing is creating an inspect class map to match the traffic to be allowed from the inside zone to the internet. So now we're going to do some more, another class map to match traffic that's allowed from the conference zone to the internet as well. So we'll just exit out of this. Another class map type, and we're going to inspect, match any again, and this time we're going to call this one Confroom Protocols. Okay, and we're going to match the protocols HTTP. We're going to match protocols HTTPS, match protocols DNS as well. Okay, so moving on, it says now that the class maps are created, you can create a policy map. So as I say, for those that know, you first create your class maps, then you create your policy maps. Okay, so we're going to do that now. So it says in the commands below, the first line creates an inspect policy map named inside to internet. The second line binds the previously created inside protocols which we've just created, class map to the policy map. All packets matched by the inside protocols class map will be subject to the action taken by the inside to internet policy map. So basically what we're doing is we're binding the class map and the policy map now. Okay, so what we're going to do now, policy map type, and we're going to inspect, and we're going to call it inside to internet, and class type inspect inside protocols, which is what we've just created up here. There we go. Okay, and we'll do inspect, come out of that, and we're going to do another policy, just come out of that, policy map type inspect, and this one we're going to call conference room to the internet, or conf room to internet. Okay, and we're gonna class type inspect, and again we're gonna bind the previous class map. So what's the name? Conf room. There we go. I lost the name then for a second. Protocols. And again, I'm going to inspect this. Exit, exit. So that's our policy maps and class maps now created. We're now going to move on to step 3, which is creating the zone pairs. So basically, zone pair allows you to specify an unidirectional firewall policy between two security zones. And it says, for example, a commonly used security policy dictates that the internet network can initiate any traffic towards the internet, but no traffic originating from the internet should be allowed to reach the internal network. The policy requires only one zone pair internal to internet because the zone pairs define unidirectional traffic flow. Another zone pair must be created if the internet initiated traffic must flow in the internet to the internal direction. Okay, so it says, notice that Cisco zone-based firewalls can be configured to inspect traffic that moves in the direction defined by the zone pair. In the situation, the firewall watches the traffic and dynamically creates rules allowing the return or related traffic to flow back through the router, which is kind of like stateful inspection. Okay, so what we're going to do is we're actually going to create the zone pair. I'm not going to read it all to you, so we're actually just going to do the configurations. So we'll start by doing zone pair security inside to internet, and source is inside, destination is internet. Okay. Same again for the conference room to the internet. So we're going to zone pair security conf room to internet, source conf room, destination internet. Enter. So now it's asking us to verify the zone pairs and check they were created correctly, issuing the show zone pair security. So you can see that we've got our zone pairs now. So we've got the inside to the internet. So the source zone is inside, destination is the internet. We have a service policy not configured yet, and we also have then the zone pair conference room to internet as well. So now we're going to actually apply the security policies. So to do this, we'll do the following. Service policy type, inspect, inside to internet. So that's what we created earlier. We'll do the same for the conference to internet. Service policy type, inspect, conf room, okay, and that completes that. So what we're going to do again is we're going to issue this show zone pair security again, and we should see the service policies now applied. So there you go. So in the previous show zone pair security we could see that no service policy was configured on either zone pair. Now after we've just done the configurations for the service policies, we can now see that we now have the service policies applied. Okay, so we can obtain more information about the zone pairs, their policy maps, the class maps, and match counters by using the following command. I'll just do this that easy use. Show policy map. Yeah, that should be it. Show policy map. Type inspect zone dash pair. Okay, so we can see a lot more detailed information on these actual policy maps. You can see drops, any packets. We can see a lot of information here, which is always useful. So now we're going to, now that we've actually created the class maps, policy maps, and we've done the zone pairs, what we're going to do is move them to step 5, which is actually assigning interfaces to the proper security zones. So we're going to assign the E01 in our case, which is the conference room zone, to the conf room security zone to start with. Oops. Zone member security. Okay. And we'll do the same for the other interfaces. So in my case, the inside is Ethernet 00. We'll call that inside. And then interface serial 2.1. We call this internet. So now we're going to actually verify that these commands have taken effect. Show zone security, and now we can see what zones each one is now a part of each interface. Okay, so now we're actually going to verify that the zone-based firewall functions. So what we're going to do is we're going to ping PCB from PCA. In PCA, open the command prompt and issue ping . So yeah, we'll do that. So PCA, we're going to ping PCB. And as you can see now that we've created the policies, we can see that traffic's actually now being dropped. It's actually not reaching PCB as before. It was reaching PCB as shown here. The reason is because we have now implemented the zone-based firewall, and traffic is coming from the internet zone into the inside zone, which is not permitted. Okay, so now that we know that that doesn't work, so now we need to ping from PCC to PCA. So we'll do a ping 192.168.1.3. We also now see that traffic is dropping here as well. So we are now going to ping from PCA to PCB. So there we go, ping. Yep. Ping PC, sorry, that's my fault. So we're going to ping from PCB to PCA. And as you can see that traffic is permitted because it's coming from the inside zone. We can also take a look at the actual configurations after to verify this. And we are going to now ping PCA from PCC. Okay, is that what we did? 1.3, I think that's what we did already. Yep, so did it ask to ping? Yeah, we can try it again. Step 2, we are going to ping PCA from PCA, we're going to ping router 3's gigabit 01 interface. So on our case, we are going to ping router 3's internet interface. And as you can see, we can actually get to that interface, but anything behind that interface we cannot get to. So just to try it again, 3.3 is the inside zone. It should drop it, which it is. And 192.168.33.3, which is the conference room. Again, it drops it again, because this is also another zone. So just before we finish off this, just run back to route 3. We'll do a not that command, sorry. We'll do a show policy map type inspection zone pair. And as we can see there, we can see we've had packets transmitted, ICMP packets, no HTTP, HTTPS packets, no DNS packets. UDP, ICMP, so as we were sending a ping, that's the ICMP packet that's being caught. So there you have it, that's the lab 4.4.1.2 configuring zone-based policy firewalls complete. There is a optional extra on this lab. If you have the lab manual, you will see that, but that's it for now. Thank you for watching.